Welcome. We are starting this video with one-step equations. One of the biggest things when we are solving one-step equations that we want to focus on is that we are always trying to isolate the variable in the equation. So in the examples that I'm going to use, we are trying to isolate the x, meaning we are trying to get x by itself on one side of the equation or one side of the equal sign. We also want to keep in mind our operations that we see and their inverse operations. So when we see addition, we want to undo addition with its inverse operation, subtraction. When we see subtraction, we want to undo subtraction with its inverse operation, addition. When we see multiplication, we want to undo with its inverse operation, division, so on and so forth. So to start, I always like to draw a dotted line through my equal sign to remind me to keep my equation balanced. Whatever happens on one side of the equal sign has to happen on the other side of the equal sign. So if I see a positive 3 or a plus 3 after the x, in order to move this plus 3 to the other side, I want to do the inverse operation of addition, which is to subtract. So I will subtract 3 to the other side. Positive 3 minus 3 is 0, which is why you'll see us cross that out and just be left with the x. So on this side I get x by itself, on the other side 9 minus 3 is 6. If you wanted to check your work, you can do 6 plus 3 equals 9, meaning we take the 6 and put it back in where we saw that highlighted x before to see if the equation remains true. And 6 plus 3 is 9, so the equation matches on both sides. In the next example, I see x minus 3. If I have a subtraction of 3, I want to do the opposite. So I want to undo subtraction with addition. So if I see minus 3, I'm going to add 3 to both sides. This allows me negative 3 and positive 3 would make 0, leaving just x on the left, and 9 plus 3 is 12 on the right. Now the order in number 3 looks a little bit different. Here we can see that the x is closer to the equal sign, but we still have this 3 that's being added to the x. Since the 3 does not have a sign in front of it, we can understand that the 3 is positive, and we want to undo this positive 3 by subtracting 3 to the other side. Okay, so 3 minus 3 becomes 0 on this side, leaving us with just the x, and 9 minus 3 on this side becomes 6. And again, you can check that by putting 6, substituting it back in for x, and seeing if it's equal on both sides. Okay, when you see a variable attached to a number, okay, this number is what we call the coefficient. When the number and the variable are attached like this, the operation that they are connected by is multiplication. So when we are looking for an inverse operation, we want to think of this as negative 2 times x, which means we need to undo multiplication with division. So we're going to divide both sides by negative 2 and get x equals negative 5. On this side, the negative 2's here. Negative 2 divided by negative 2 becomes 1, which is why there's just an x left over on the left and a negative 5 on the right. You could have also asked yourself before you started, if this x here, I'm thinking of a number, that x represents a number, negative 2 times what number would give me 10? And that's where the negative 5 also comes from. Example 5. Most of us will read this as x over 3 equals 5. But we want to focus on that symbol, the fraction bar, representing division. So x divided by 3 equals 5. In order to get the x by itself, we want to undo division with multiplication. So I'm going to multiply both sides by 3. The reason that these 3's are gone is because 3 divided by 3 would give us 1x, and on this side, 5 times 3 is 15. One other note I want to make, similar to example 3, is had the number in front been negative, we would have had the same procedure. It just would have been an adding 2 to both sides to get the x by itself and get 10. That's it for one-step equations. You might want to consider going forward and looking at one-step inequalities as well in your next video.